So in this tutorial, we are going to simplify a complex expression. Let's get straight to what we have in this tutorial. So I have z to be equal to I plus 1 all to the power 3, 1 minus I, that is over 1 minus I. So how do we simplify this expression? We can use the method called, we are going to use the de Moivres theorem, as well as the polar expression of complex numbers, polar expression. So let's start. So in order to divide any two complex numbers, the first thing to do is to convert it into polar form. So convert it into polar form. So once in the polar form, then let's see what to do. So let's see. In the polar form, I plus 1, that is what is inside here, all to the power 3 will be equal to r angle theta all to the power 3, which was also going to be r e to the power I theta. Now let's find r. R is simply equal to the square root of what? The coefficient here is 1 squared plus the coefficient or the number here, which is what? 1 squared. This is going to give me square root of 2. My theta is simply equal to tan inverse of the coefficient of my imaginary number over my real number, and that is going to give me pi on 4, which is the same as 45 degrees. So here I'm using pi on 4. Therefore, I plus 1 is simply equal to my r square root of 2 multiplying e to the power I pi on 4. Right. Therefore, I plus 1 all cubed will be equal to the expression e to the power I pi on 4 all to the power 3. So at this point, let me simplify the expression. So at this point, we are going to have here, you get square root of 2 to the power 3. Then by the Moivres theorem, 3 will multiply what we have here. So you have 3 pi on 4i, right? Now let's convert the denominator to also polar form. So to convert the denominator also in polar form, you simply have to, the denominator is 1 minus I. So to convert it to polar form, we simply have to, so 1 minus I, and if you want to convert 1 minus I to polar form, your r is simply going to be the square root of 1 squared plus the coefficient of our I, which is negative 1 squared, right? This will be equal to what? Square root of what? 2. Now the angle theta will be equal to tan inverse of the coefficient of the imaginary negative 1 over this r1. This is giving us negative pi on 4, right? So once we get this, we come back to our expression. Z is equal to 1 plus I all cubed all over 1 minus I. This will be equal to the expression that we have here, which is square root of 2 all cubed multiplying e to the power 3 pi on 4i, all out of this place we had our r to be square root of 2 multiplying e to the power negative pi on 4i. At this point, we can clearly see that square root of 2 will go here, square root of 2, 2. It will cancel 1 and we left with 2. Then here, by indices, you will subtract. So e to the power 3 pi on 4i minus pi on 4i. This square root on 2 squared is the same as what? 2. Then this place you get plus. So 3 pi on 4 plus pi on 4 will be what? 4 pi on 4. So e to the power 4 pi on 4i. This is the same as 2e to the power pi i. The 4 will cancel 4. And our expression is the same as 2 cos 2 out, that is the r out, cos pi plus I sine. So I sine pi. And that is the solution for our problem given. Please subscribe for content like this.